travel back about 20 million years, you wouldn't recognize the Amazon. It was a vast super lake inhabited by terrifying prehistoric creatures. What happened to this ancient South America, and what ultimately created the Amazon we know today? The answer is stranger than most people have ever imagined. A massive pair of jaws erupts from the muddy water, snapping shut with incredible force. The giant turtle struggles to break free, but escape is almost impossible. It remains still. Then a school of fish suddenly scatters. A giant turtle moves cautiously through the shallows. Beneath the surface, something enormous lies motionless, patiently waiting in the muddy water. Pebas was not only a thriving paradise, it was also home to one of the largest predators ever to live in South America. Then, in a split second, the moment of truth arrives. The attack begins. With a powerful twist of its body, the predator pulls its catch deeper into the ancient wetland. This was PURUSSAURUS, the undisputed ruler of Pebas. The entire attack lasted only a few seconds, but it was the result of millions of years of evolution. At nearly 40 feet in length and weighing close to 8 tons, PURUSSAURUS was built for ambush. Its skull alone could exceed 5 feet in length, armed with thick, cone-shaped teeth. Together, they allowed this prehistoric crocodilian to maintain an incredibly powerful grip on anything it caught. Scientists estimate that its bite may have exceeded 15,000 pounds of pressure, making it one of the most powerful bites ever produced by a terrestrial vertebrate. But size alone was not what made PURUSSAURUS so successful. Its greatest advantage was patience. Most of its massive body remained hidden beneath the muddy waters of Pebas. Only its eyes and nostrils broke the surface as it waited motionless for the perfect moment. Then, with a sudden burst of speed, it lunged upward. Powerful jaws snapped shut, massive neck muscles tightened their grip, and the struggling animal was pulled toward deeper water. There, PURUSSAURUS likely employed a strategy similar to that used by modern crocodilians today, a powerful spinning maneuver. By spinning its entire body, it could use its own weight to overpower prey far too large to swallow whole. It was a hunting strategy that had been perfected over millions of years, and it explained why so few animals managed to escape once an attack had begun. PURUSSAURUS stood at the top of the Pebas food web. Fish, giant turtles, smaller crocodilians, and almost any animal that ventured too close to the shoreline could become a meal. But another question remains. Why did PURUSSAURUS become so large and so formidable? The answer may lie in Pebas itself. For millions of years, this immense wetland remained warm throughout the year. Rivers flowing from the young Andes continuously delivered nutrients into the basin, supporting vast populations of fish and aquatic life. Endless channels, lakes, and murky swamps created perfect conditions for ambush hunting, while large mammalian predators were still relatively rare in northern South America. In many ways, Pebas was the ideal environment for a giant crocodilian, allowing PURUSSAURUS to reach sizes that would be almost impossible in modern ecosystems. Yet even a predator of this scale had limits. Imagine a giant Astrapitherium stepping cautiously into the shallows. Weighing several tons and armed with immense strength, it was not an easy target. PURUSSAURUS launched its attack as it had countless times before, but this encounter unfolded differently. The mammal resisted fiercely, forcing the giant crocodilian to release its grip before wasting too much energy. Not every hunt ended in success. For an animal as large as PURUSSAURUS, failed attacks carried a cost. Every ambush required energy, and every struggle carried the risk of injury. Even the greatest predators could not afford unnecessary risks. And if almost nothing in Pebas could challenge PURUSSAURUS, what could? Perhaps only another PURUSSAURUS. Imagine the carcass of a large animal drifting through the wetlands. One giant arrives first and begins feeding. Then another disturbance ripples across the water. A second PURUSSAURUS emerges from the reeds. Neither animal is willing to surrender such a valuable source of food. Fossil evidence, including bite marks found on the bones of other PURUSSAURUS individuals, suggests that confrontations like these may have occurred. Some likely involved territorial disputes. Others may have ended with scavenging or perhaps even cannibalism. Ironically, after millions of years as the undisputed ruler of Pebas, the only predator truly capable of challenging PURUSSAURUS may have been another PURUSSAURUS. Around 20 million years ago, the landscape of the ancient Amazon was dramatically different from what it is today. There was no tropical rainforest, and there was no modern Amazon River. Instead, much of northern South America was covered by a vast network of wetlands, lakes, and swamps, known as the Pebas system. Rivers carried enormous amounts of sediment into the basin, creating nutrient-rich waters under a warm and humid climate. These conditions allowed life to flourish on an extraordinary scale. Fish diversified, giant freshwater turtles appeared, and many ancient reptiles evolved into forms unlike anything seen in the modern world. Over millions of years of abundant resources and environmental stability, some of these reptiles began pushing the limits of size, growing far larger than any of their living relatives. PURUSSAURUS was only the beginning. The same conditions that created its dominance also allowed many other extraordinary giants to evolve along completely different evolutionary paths. But Pebas still held many surprises. Not every crocodilian followed the same evolutionary path. While PURUSSAURUS became the ultimate ambush predator, another giant evolved in a completely different direction. That animal was MOURASUCHUS. MOURASUCHUS lived alongside PURUSSAURUS throughout the vast wetlands of the Pebas system. From a distance, it looked much like any other crocodilian. But a closer look revealed something completely unexpected. Its head was unlike anything seen in either ancient or modern crocodilians. Its skull was remarkably large, incredibly wide, and unusually flat. Nothing like the deep, powerful jaws of PURUSSAURUS. The snout extended outward like an enormous spoon, giving MOURASUCHUS one of the strangest appearances ever known among crocodilians. Yet, despite its impressive size, its jaws lacked the strength needed to overpower large prey. It could not subdue giant mammals, and it almost certainly avoided direct confrontations with PURUSSAURUS. So why would evolution produce such an unusual design? For decades, paleontologists debated how MOURASUCHUS actually fed. As more fossils were studied, a different explanation gradually emerged. The unusual shape of its skull, its relatively weak jaws, and the structure of its teeth all pointed toward a feeding strategy unlike that of any other giant crocodilian. That evidence also helps answer the question. Instead of ambushing large animals, MOURASUCHUS may have moved slowly through shallow wetlands with its mouth held open, sweeping through mud, aquatic vegetation, and soft sediment. With each pass, it could have gathered fish, crustaceans, mollusks, amphibians, and countless other small animals hiding beneath the water. Rather than relying on strength, MOURASUCHUS relied on abundance. And Pebas offered exactly that. Nutrient-rich waters supported enormous populations of small aquatic animals across the ancient wetlands. Food was everywhere. With a single powerful snap of its massive jaws, it could seize countless tiny prey at once, making this highly unconventional hunting strategy incredibly effective. And it worked. For millions of years, MOURASUCHUS thrived alongside one of the largest predators ever to inhabit South America. Imagine a quiet channel deep within the Pebas wetlands. On one side, a PURUSSAURUS lies motionless beneath the muddy water, waiting for a large animal to wander within striking distance. Nearby, a MOURASUCHUS moves slowly through the shallows, sweeping the bottom in search of countless small creatures hidden beneath the sediment. Two giants shared the same waters, yet they had little reason to compete. Why? At first glance, that seems difficult to explain. Both were enormous crocodilians living in the same ecosystem. But size alone does not determine competition. What truly matters is whether two species depend on the same resources. That also explains how they coexisted for millions of years. PURUSSAURUS specialized in large prey, while MOURASUCHUS focused on vast numbers of small aquatic animals. By exploiting completely different food sources, each occupied its own ecological niche. This division of resources became one of the keys to the extraordinary biodiversity that made the Pebas system unlike any freshwater ecosystem on Earth. In a world dominated by giant predators, some animals survived not by becoming hunters, but by becoming incredibly difficult to overcome. Among them was Stupendemys geographicus. Stupendemys moved across the landscape like a living fortress, drifting through the Pebas wetlands. Its enormous shell protected a body far larger than any freshwater turtle alive today, allowing it to move through rivers, lakes, and flooded plains that stretched across ancient Amazonia. For millions of years, this strategy was extremely effective. Stupendemys spent much of its time moving slowly through the shallow wetlands in search of aquatic plants, fruits, and other vegetation. But every trip in search of food also brought the possibility of danger. This time it encounters a PURUSSAURUS. The giant crocodilian has little reason to ignore such a large opportunity. It surges forward and clamps its powerful jaws around the turtle's shell. Even so, Stupendemys is far from an easy animal to overpower. Its enormous size and heavily armored shell allowed Stupendemys to escape this encounter. After a tense struggle, the giant turtle manages to break free and slowly disappears back into the shallow waters. Even more remarkable, some of these injuries show signs of healing, suggesting that at least a few individuals escaped attacks that should have been fatal. But survival was not the only challenge facing Stupendemys. There was also competition. Some male individuals possessed an unusual feature rarely seen among turtles: a pair of horn-like projections extending from the front of the shell. Why evolve such structures? One possibility is that they served as weapons during contests between males. Picture two giants facing one another in shallow water, pushing and twisting as each attempts to force the other backward. These encounters may have determined access to territory, nesting sites, or mates. If so, the horns of Stupendemys were not built to fight predators. They were built to compete with rivals. It is a pattern seen throughout nature. Survival is only half the battle. Passing on genes to the next generation is just as important, and over millions of years, sexual selection may have shaped some of the most unusual features in the animal kingdom. For Stupendemys, armor allowed it to survive in a world ruled by giant crocodilians. But Pebas was more than a collection of extraordinary species. It was an entire ecosystem operating at a scale almost unimaginable today, where giant predators, giant turtles, strange crocodilians, and ancient river dolphins all shared the same waters. Pebas had become a paradise for giants. For millions of years, Pebas reached its peak. Warm waters, abundant nutrients, and endless wetlands supported one of the richest ecosystems South America had ever seen. But its true secret was specialization. Each giant occupied a different niche, allowing many enormous species to thrive side by side without directly competing. Nearby, another crocodilian patrolled the channels. MOURASUCHUS looked very different from PURUSSAURUS. Its long, slender snout was built for catching fish rather than overpowering giant prey. While PURUSSAURUS dominated the largest animals, MOURASUCHUS focused on smaller, faster targets, avoiding competition with the giant predator altogether. Even the skies above Pebas were filled with hunters. Ancient water birds and birds of prey searched for fish, juvenile reptiles, and small animals along the shoreline. From the muddy bottom to the open sky, every level of the ecosystem was occupied. In Pebas, there were giants everywhere, and nowhere was ever truly safe. This lost world had reached the height of its diversity, but it would not last forever. For millions of years, Pebas seemed eternal. But deep beneath the surface, South America was changing. The Andes continued to rise, gradually reshaping the continent itself. Rivers were diverted, wetlands became isolated, and the vast inland waters that had sustained Pebas for so long began to disappear. Slowly, the ancient swamps shrank. The Great Lakes became smaller. Food became harder to find. For For specialists like MOURASUCHUS, the consequences were severe. Its feeding strategy depended on shallow wetlands teeming with small aquatic animals. As those habitats vanished, so did its source of food. Stupendemys faced a different challenge. Fewer wetlands meant fewer nesting grounds, and populations that had once been connected across Pebas became increasingly isolated. Competition intensified. Resources declined. And even PURUSSAURUS, the giant that had ruled these waters for millions of years, could not escape the transformation. As Pebas fragmented, its populations retreated and eventually disappeared from much of the ancient basin. An entire ecosystem shaped over millions of years was fading away. But from its decline, something new would emerge millions of years later. The land of Pebas gave way to swift rivers and dense forests spreading across the basin, and the foundations of the modern Amazon rainforest were finally laid. Then, after millions of years, a new arrival entered this transformed world. By the time the first groups of Homo sapiens reached the Amazon, Pebas had already been gone for millions of years. The vast wetlands that once sheltered PURUSSAURUS MOURASUCHUS and Stupendemys had been replaced by dense rainforests, winding rivers, and seasonally flooded forests. It was a completely different world, yet one that remained just as challenging to survive in. For early humans, the Amazon was not an easy place to conquer. They adapted their lives around fishing, gathering fruits, and hunting the animals that inhabited the flooded plains. But even this new Amazon still belonged to powerful predators. In the dark and humid rainforest, giant snakes could remain perfectly still for hours. They waited for an unsuspecting animal to come within striking distance. Along the riverbanks, crocodilians still lay in ambush. They continued a hunting strategy that had endured for millions of years. For the first people to enter the Amazon, every journey through the forest carried hidden dangers. Every river crossing and every path through the forest could conceal a deadly predator. Surviving this wilderness required constant awareness. Survival in the Amazon still demanded constant awareness, just as it had for the creatures that inhabited this region millions of years before. It remains one of the most demanding environments on Earth for humans. But humans possessed something no other species had ever developed. They could change the environment itself. Over time, humans learned to cultivate crops, manage forest resources, and establish permanent communities along rivers and floodplains. They skillfully used their intelligence to clear vegetation and reshape the landscape. Plants were domesticated. The land was gradually transformed to support growing populations. And so, after tens of millions of years of geological change, extinction, and adaptation, the modern Amazon finally emerged a rainforest unlike any other on Earth, built upon the legacy of an ancient world that had long since disappeared.
"99% of all species that have ever lived on Earth are gone. What we call the natural world today is only the latest version of a planet that has been erased and rewritten many times. Earth did not always belong to mammals, birds, or humans. Long ago, there were forests where giant insects ruled the air, and strange creatures crept through vast swamps. Most of these animals are forgotten. Some left no descendants. Others vanished in the mass extinctions. Many were simply overshadowed by the later fame of the dinosaurs. But this is not a story about the strongest creatures. This is the story of lost worlds and the remarkable animals that once ruled them. To understand them, we must return to a very different Earth. Around 320 million years ago, Earth entered the Carboniferous period. Vast swamp forests spread across warm lowlands. Towering ferns and ancient club moss trees formed dense green canopies above dark wetlands. The air itself was unusual. Oxygen levels may have reached nearly 35%. That is far higher than the 21% we breathe today. Insects do not have lungs. They breathe through tiny openings along their bodies. Air flows through these openings into a network of internal tubes. In an oxygen-rich atmosphere, this system works far more efficiently. The result was a world where some prehistoric creatures grew to astonishing sizes. High above the swamps flew Meganura. At first glance, it looked like a dragonfly. The difference was its scale. Its wings stretched nearly 2 feet from tip to tip. Each wing alone could reach about 13 inches in length. Its large compound eyes and powerful wings made it an efficient aerial hunter, feeding mainly on other insects in the humid forests of the Carboniferous period. On land, an even more remarkable animal appears. Arthropleura was the largest land arthropod ever discovered. Its body resembled a giant armored millipede. The armor likely protected it from the large amphibian predators of the Carboniferous forests. Fossils suggest it could grow longer than 8 feet 2 inches. Some fossil trackways left by this creature measure more than 20 inches across. Despite its immense size, Arthropleura likely fed on decaying plants and forest litter. Around it lived a rich community of ancient animals. Early amphibians moved through the wetlands, while some of the first amniotes also appeared in these forests. Among them was Hylonomus, a small reptile about 8 inches long that lived among the swamp forests of the Carboniferous period. Unlike amphibians, it laid amniotic eggs. These eggs could develop safely on land. This simple adaptation allowed vertebrates to move beyond water and spread into new environments, shaping the future of many prehistoric creatures. Yet the Carboniferous world would not last forever. The climate began to change. Vast forests fragmented and gradually disappeared in an event known as the Carboniferous Rainforest collapse. In the millions of years that followed, Earth entered a new chapter, known as the Permian period. Across these expanding dry lands lived a variety of prehistoric creatures belonging to an important group known as synapsids. These animals were not dinosaurs. In fact, they lived tens of millions of years before the first dinosaurs would appear. Synapsids were part of an ancient lineage that would eventually lead to mammals. Among the most recognizable predators of the early Permian was Dimetrodon. Dimetrodon could reach lengths of roughly 6 to 15 feet. Its skull alone could grow more than 50 centimeters long, filled with strong teeth designed for gripping and tearing prey. Unlike many earlier reptiles, its teeth were specialized. Some were long and pointed for piercing, while others were shaped for slicing flesh. Yet the most striking feature of Dimetrodon rose high above its back. A tall sail formed by elongated neural spines stretched between thin skin membranes. In some individuals, these spines exceeded 1.5 meters in height. Scientists believe the sail may have helped regulate body temperature. It could absorb sunlight and warm the animal more quickly. This advantage may have allowed Dimetrodon to become active earlier than many of its competitors. For millions of years, animals like Dimetrodon stood among the dominant predators of their ecosystems. They were powerful hunters in a world that was already growing more challenging. But the Permian world held even more formidable hunters. Later in the period, another group of predators rose to prominence. These were the Gorgonopsians, members of the group known as Gorgonopsia. Gorgonopsians were among the most formidable land predators of the late Permian. Some species reached lengths of about 11 feet. Long limbs and flexible spines allowed them to move quickly across the dry floodplains and sparse woodlands that dominated the landscape. Their most distinctive feature was their teeth. 2 long saber-shaped canines extended from the upper jaw, sometimes reaching over 10 centimeters in length. These fangs were designed to deliver deep, powerful bites. With keen senses and strong jaws, Gorgonopsians hunted large herbivores that roamed the Permian plains. For a time, these predators stood at the top of the food chain. Together with many other synapsids and primitive reptiles, they formed a complex ecosystem of prehistoric creatures adapted to the challenges of the Permian climate. Near the end of the Permian, the planet entered one of the most dramatic turning points in the history of life. Massive volcanic eruptions began in what is now Siberia. Global temperatures rose sharply. Ocean chemistry changed. Ecosystems across the planet began to collapse. Many of the synapsids that had once dominated the Permian world, including the powerful Gorgonopsians, disappeared entirely. The landscapes they once ruled grew strangely empty. Yet extinction rarely leaves a world silent for long. After the end Permian catastrophe, life did not return to order, but to chaos. And so the world entered the Triassic, a harsh, unstable age where new groups began to compete for the empty roles left behind. The Triassic period began around 252 million years ago. Many strange animals lived together in the same environments. Among the most important were the early archosaurs. This group of reptiles would later give rise to crocodiles, pterosaurs, and dinosaurs. Their limbs were positioned more upright beneath the body, allowing them to move more efficiently across open land. Archosaurs likely had a unidirectional airflow respiratory system, allowing efficient oxygen exchange as air moved through their lungs in a continuous one-way flow. This system, similar to that seen in birds and crocodiles, may have given them greater endurance in the hot environments of the Triassic period. At the same time, a new kind of animal appeared in the skies: pterosaurs. Early pterosaurs evolved in the late Triassic, around 225 million years ago. Some of the earliest known species had wingspans of about 6.6 feet. Their wings were formed by thin membranes of skin stretched along a greatly elongated finger. With lightweight bones and strong flight muscles, these animals became the first vertebrates capable of sustained powered flight. Today, most of these early archosaurs are known only from scattered fossils. Their names rarely appear in popular history, yet they were among the first creatures to rebuild life after the greatest extinction Earth had ever seen. Despite the rise of archosaurs and flying pterosaurs, some ancient lineages from the earlier synapsid world managed to survive. One example is Thrinaxodon. This small animal measured roughly 30 to 50 centimeters in length and lived much of its life in underground burrows. These shelters protected it from predators and from the extreme temperatures of the Triassic surface. Fossils have even been discovered preserved inside these burrows. Thrinaxodon possessed several features that hint at the later evolution of mammals. Its teeth were specialized for slicing and chewing, and its skull structure allowed more efficient feeding than many reptiles of the time. Across the Triassic landscape, archosaurs walked the open plains, early pterosaurs explored the skies, and small synapsid survivors remained hidden below the ground. The world was still searching for stability, and many of the animals of this era would become forgotten creatures of prehistory. As the Jurassic period began about 200 million years ago, life on land entered a new chapter. Many of the earlier reptiles that once shared the recovering Triassic landscapes faded away, while others continued to evolve into new and unfamiliar forms. Warm climates and steady rainfall allowed forests to spread across much of the planet. Tall conifers, cycads, and thick ferns covered the landscape. In these green environments, dinosaurs grew larger and more diverse than ever. One of the most well-known hunters of this time was Allosaurus. Fossils of this predator have been found mainly in the Morrison Formation of the western United States. adult Allosaurus could grow about 28 to 32 feet long and weigh roughly 2 tons. Strong hind legs allowed it to move quickly, while its powerful jaws made it one of the dominant predators of the late Jurassic landscape. Evidence from fossil sites suggests that Allosaurus preyed on many of the large plant-eating dinosaurs that lived beside it. Bite marks found on bones of animals such as Stegosaurus and Apatosaurus indicate that these giants were part of its food sources. Its skull measured more than 3 feet in length and contained dozens of sharp, serrated teeth built for slicing through flesh. Instead of relying only on bite force, Allosaurus may have used its strong neck muscles to drive the upper jaw downward like a hatchet. This motion allowed the serrated teeth to slice deeply into prey before pulling back again. Some fossil sites also contain large numbers of Allosaurus remains together. This has led some scientists to wonder whether these predators may have occasionally gathered around carcasses or hunted in loose groups, though this behavior is still debated. In the Jurassic world, Allosaurus stood among the most formidable predators, a fast and powerful hunter moving through forests that were filled with enormous herbivores. Sharing those forests and floodplains was Diplodocus. This giant plant eater could reach lengths of about 80 to 85 feet with a long neck and an equally long tail. Despite its massive body, its head was surprisingly small. Its narrow teeth were shaped like pegs and were suited for stripping leaves from branches rather than chewing. Diplodocus likely spent much of its time feeding on large amounts of vegetation to sustain its enormous size. Not all Jurassic dinosaurs relied on size alone for protection. Some evolved armor to defend themselves from predators. One early example is Solidosaurus. This herbivore lived during the early Jurassic and reached about 13 feet in length, weighing around 600 pounds. Its body was covered with rows of bony plates set into the skin. These protective structures formed a natural shield that could discourage attacks from predators. Solidosaurus is considered one of the earliest known armored dinosaurs and may represent an early stage in the evolution of later armored groups. Throughout the Jurassic, dinosaurs diversified into many different forms. Some evolved massive bodies to feed on tall vegetation, while others developed speed, sharp teeth, and keen senses for hunting. Yet some of the most important changes were happening among smaller dinosaurs, whose bodies were beginning to develop simple, feather-like filaments that would eventually reshape the story of prehistoric creatures. much of the 20th century, dinosaurs were imagined as giant reptiles covered only in scales. Their skin was thought to resemble that of modern lizards or crocodiles. But a series of remarkable fossil discoveries in northeastern China began to change that image. In the province of Liaoning, layers of fine volcanic sediments preserved animals in extraordinary detail about 125 million years ago. These fossils revealed that many prehistoric creatures carried feather-like structures. Some appeared as simple filaments, while others formed complex feathers similar to those of modern birds. One of the first dinosaurs to reveal this feature was Sinosauropteryx. This small predator measured a little over 3 feet long. Fossils show a covering of simple filaments along its back and tail. Even more remarkable, microscopic structures known as melanosomes, preserved in the fossil, suggest that its tail displayed alternating orange and white bands. It was one of the first times scientists could reconstruct the color pattern of a dinosaur. Another discovery from these deposits was Yhcum. This predator lived about 125 million years ago and could reach nearly 30 feet in length. Fossil impressions indicate that parts of its body were covered with long, filamentous feathers. The find showed that feather coverings were not limited to small animals and may have helped large dinosaurs survive in cooler climates. Some species revealed even stranger experiments. Microraptor was a small dinosaur about 3 feet long with flight feathers on both its arms and legs. These 4 wing surfaces may have allowed it to glide between trees in dense forests. Other fossil discoveries in China revealed an even earlier feathered dinosaur. Anchiornis lived during the late Jurassic, around 160 million years ago. About the size of a modern crow, it carried long feathers across much of its body. Detailed fossil studies even reveal patterns of black, white, and reddish plumage. These discoveries suggest that feathers first evolved for insulation or display before later becoming useful for flight. The fossils of Liaoning reveal that many dinosaurs already carried bird-like features long before birds became common. Yet, while feathered dinosaurs moved through the daylight forests, another group of small animals continued living quietly in the shadows of this ancient world. For many years, early mammals were portrayed as small, simple creatures that survived only by avoiding dinosaurs. Yet fossil discoveries reveal a far more complex story. Some climbed through trees, others dug burrows underground. A few even developed the ability to glide between branches. Though they rarely dominated the landscape, they quietly filled many ecological roles across ancient ecosystems. One remarkable example is Repenomamus. This animal was unusually large for an early mammal, reaching more than 3 feet in length. Fossil evidence discovered in northeastern China preserved the remains of a small dinosaur inside its stomach. The discovery suggests that some mammals were not always passive survivors. At times, they may have hunted young dinosaurs or scavenged their remains. In rare moments, the roles between hunter and hunted could briefly reverse. Another unusual species is Spinolestes. This small mammal lived about 125 million years ago and is known from remarkably detailed fossils. The remains reveal thick fur, protective spines along parts of the body, and a well-developed middle ear structure, similar to that of modern mammals. These features show that many familiar mammalian traits had already evolved deep in the age of dinosaurs. Scientists have also uncovered some of the earliest ancestors of placental mammals. One of the most discussed is Jeremiah. Fossils attributed to this animal date to roughly 160 million years ago during the Jurassic period, though its exact age and evolutionary position remain debated among researchers. Its skeleton suggests a small animal with long limbs and grasping feet that may have allowed it to climb among branches. Some species even explored life in the air. Velaticotherium possessed a membrane of skin stretched between its limbs that allowed it to glide from tree to tree, much like modern flying squirrels.
From Chinese and Latin,
several traits helped these animals
feather,
survive in a world filled with
and weighed
larger
around
reptiles.
1.5 tons,
Fur helped retain
about the
body
size
heat.
of a
Mothers fed their young with
forward-facing
milk,
eyes
greatly
gave it
improving
depth
survival.
perception for that. Scientists suspect earthy browns, ashy gray.
Sensitive hearing allowed them to detect faint sounds in darkness, while specialized teeth helped them eat insects, plants, and other small foods. Their small size was not simply a weakness, it was a flexible survival strategy. The history of life is not written only by giants. Many chapters belong to quieter, prehistoric creatures that adapted patiently while the rulers of their age slowly faded into the lost worlds of prehistory.
Mà bạn có thể dễ dàng xua đuổi bằng một cái phẩy tay chém khổng lồ, cai trị cả bầu trời lẫn mặt đất, tát thẳng vào những gì bạn từng biết về giới hạn của sự sống. Chào mừng bạn đến với Nhìn xuống lớp lá mục. Bạn sẽ chiếc ô tô cỡ nhỏ đang rầm rập bò qua những khúc cây đổ, con chuồn, con rết bằng lòng bàn tay của thời hiện đại. Sự chênh lệch là quá sức in thẳng vào động cơ sinh học cổ đại, nhưng khoan đã. Oxy dồi dào thì liên của chúng ta không biến thành những gã khổng lồ, mà phần thưởng đó lại dành riêng cho loài côn trùng.
Perhaps the greatest lesson from these lost worlds is simple. No species rules this planet forever. And one day, if the world changes again, perhaps we too will become only a short chapter in the long history of life on Earth. If you could travel back in time, which prehistoric creature would you most want to see? Let us know in the comments below.